Alrighty, again, we want to consider the situation, and we want to remember that when we're told this information, that g of x equals the integral from a to x of f of t dt by the fundamental theorem of calculus, we also know that g of x, or g prime of x, sorry, is the same thing as f of x. So if we're given the function of f, that's giving us information about the derivative of g. So when we're asked, when is this increasing? Well, here's a question. When is a function increasing? We know a function is increasing when its derivative is positive. But we know that the derivative is positive when f is positive, because they're the same thing. So if the derivative is positive when f is positive, let's find the regions where it's positive. I see that happening here. And so my answer to this question would be g is increasing on the interval. Where does it start? It starts at 2, ends at 6. On the interval 2, 6, because g prime, or f, is positive on that interval. And now the final question that we're asked, and I'll do this in red, is this. Given h of x equals this, find the value where h has a relative minimum. And so here we're given a different function. This is not about g now, this is about h. So how would we do this? Well, we would have to follow that rule that tells us that if we have a function, so in this case h of x equals the integral of 0 to x over 2 plus 4 f of t dt. When we find h prime, which we're going to need because we're looking for a relative minimum, we care about the derivative. H prime of x equals f of x over 2 plus 4 times the derivative of what's on the inside. So that's going to be the derivative of the inside was x over 2 plus 4. The derivative of that is 1/2. Alright, so here we are. H prime of x equals f of x over 2 plus 4 times 1/2. And so we need to figure out, when is there a minimum? Well, a minimum occurs when that derivative equals 0. So let's set that equal to 0. 0 equals 1/2 f of x over 2 plus 4. I can divide both sides by 1/2. So we'll get 0 equals f of x over 2 plus 4. And remember, there's two things that need to be true. It needs to be 0, and the thing needs to change from negative to positive, right? And I can see that happening here. My f is changing from negative to positive. Where does that happen? At x equals 2. So that means 0 equals f of 2. But that's not our answer. X equals 2 is not our answer. 2, and that's why this is tricky. 2 is x over 2 plus 4. So our next step, and I'll do this in green, is we have to set up one more equation. 2 equals x over 2 plus 4. I'm going to subtract 2 on both sides. So I'm going to get negative 2 equals x over 2. And by multiplying by 2 on both sides, I find that x equals negative 4. So our final answer here is that x equals negative 4. It's a little tricky, but I hope that we could see exactly where this is coming from. Actually, I see that we can't see part of this. So let me draw an arrow up here. I subtracted 2 from both sides, so that was negative 2 equals x over 2. And then by multiplying on 2 on both sides, we got our final answer of x equals negative 4. Whew! A little tricky, a little sneaky, but just takes a little bit of practice.